Hi, I'm Andy and this is question 8 on the AQA Decision 1 paper from June 2014. For more questions on this exam paper, click the eye in the top right corner. In question 8, we're told we may use the fact that any simple graph must have an even number of vertices of odd degree. And in part A, it says a simple graph has 5 vertices and their degrees are x, x plus 1, x plus 1, x plus 2 and x plus 3. And in part 1, we must show that x is odd. So here is the order of our vertices, and we're told the fact that any simple graph must have an even number of vertices of odd degree. That means we could have maybe 2 vertices that are odd, 4 vertices that are odd, and so on. So what we can do is prove that it cannot be an even number by contradiction. So if we assume x is even, then the vertex x, that would have to be even, but x plus 1 has a degree 1 higher, that is going to be odd. And so would the other x plus 1. X plus 2 would be even. And x plus 3 would be odd. And that would mean there are 3 vertices with odd order. And that means that x cannot be even, which means that x must be odd. In part 2, we need to find the value of x and draw a graph with vertices having the given degrees. So if we have 5 vertices and the graph is simple, that means the max degree of any node is 4. Because if I take any individual vertex, I could connect it to 1, 2, 3, 4 others. And if I wanted to add an extra arc in, I would have to have a repeated arc, which I'm not allowed because this is a simple graph. And looking at the order of the vertices that we've got, x plus 3 is the largest. So if x plus 3 must be less than or equal to 4, that means that x must be less than or equal to 1. But since the order of a vertex must be a whole number, and from part 1 we know that x must be odd, therefore we can say that x can only equal 1. So that means that this vertex must have order 1, these two must have order 2, this one must have order 3, and this one must have order 4. So starting with the vertex with the largest order, we'll connect that to 4 other vertices. Then this one needs to be connected to 3 other vertices. So starting from here, this one's already connected to 1, so that would be 2, and then 3. And if we look at our other nodes, we've got 1 of order 2 here, 1 of order 2 here, and this one of order 1, so that matches up with what we require. In part B, it says a simple graph has 10 vertices. State the minimum possible degree and maximum possible degree of a vertex. When you're answering a question like this, it's important to look for the keywords in the question, but also the keywords that are not in the question. So here, a simple graph just means we've got no loops or repeated edges. But the keyword that is not included in this graph is connected. It doesn't say it's a connected graph. And if everything doesn't have to be connected, there's no reason why we can't have a vertex that has no arcs connected to it, so it's of order 0. So the minimum degree equals 0. And as it's a simple graph and we can't have any repeated edges, if we consider any individual vertex, it can only be connected to 9 other vertices, so the maximum degree is 9. And in part 2 it says show the degree of the vertices cannot all be different. So if there are 10 vertices, all of different degree, then the degrees of the vertices would be from 0 all the way up to 9. And if one of the vertices is connected to 9 others, that means that we can't have a vertex of order 0. Notice that for this question there are several other possible explanations that you could give. For example, if you did the sum of 0 plus 1 all the way up to 9, That would be 45. But as we mentioned earlier, the sum of the degree of all the vertices must be even. So that's another way of showing that it's not possible. Finally, a third way of showing it, the orders of the vertices would be 0, 1, all the way up to 9. And we have 1, 2, 3, 4, 5. We'd have 5 odd vertices, which, as we said in A part 1, is not possible. So take your pick for any of these reasons. You only have to give one to get all the marks.